It's time to make our first physiological measurements. Normally, in place of the music, we would have electrodes to connect to the amplifier to our patient, but times are hard. So instead of electrodes, today I've got a couple of buckets. You may well think it's an unusual choice, but in fact, the very first physiological measurements, or the very first electrophysiological measurements, were made using exactly this technique by a couple of guys round about the turn of the last century, Augustus Waller and Eindhoven, who described the first ECG. And actually, as you're going to see, it works reasonably well, or at least I hope you're going to see that. In this experiment, I've simply connected positive and the negative inputs of my differential amplifier to these two buckets. At the moment you can see, because there's nothing connected to the buckets, that they're picking up a lot of interference. That probably won't surprise you, because you saw the amount of interference that was picked up simply from the electrical cables around me. Those of you studying cardiology may not be much impressed by the quality of this ECG, but think how much money you could save on electrodes. Actually, one of the great things about this demonstration, which I can't show you today, is that if two people hold hands, you can record two ECGs at the same time. Think how much money that could save the NHS. So where has all the noise gone? Well, even though there's a lot of electrical noise on my body, much more than the ECG signal that we're trying to measure, the thing that's greatly in our favour is that that noise is more or less the same wherever you measure it across the surface of the body. In other words, it's a common mode signal. And if you think back to the demonstration we just saw using the music, you'll remember that a differential amplifier's important property is that it cancels common mode signals. That's called common mode rejection. And so even though that electrical interference might be 1,000 times bigger than the ECG that we're trying to measure, it's common mode electrical interference, and because of the design of the amplifier, that can be cancelled out almost entirely. I can agree with you that the ECG we just recorded was noisy, but actually the differential amplifier took us from what seemed to be a hopeless situation where the noise was far bigger than the signal that we wanted to record, to a situation where at least we had a usable physiological signal. Now, you might have wondered about the origin of some of that noise. Presumably it comes from somewhere in the human body. In a moment we're going to investigate that noise on the ECG a little closer, but first we need to talk about filters.